Everybody, there's no explicit punchline here, but I hope you'll stick around for it. I think this is an interesting problem. Notice that 1 is not a member of this set. The non-negative even numbers, 1 is not a member of E, right? So this could be thought of as what they call a ring. A ring is a group endowed with two operations, usually called multiplication and addition. But we do not have a multiplicative identity. 1 is not a member of this set, okay? So we can talk about an alternate definition of primality, and here it is. Now we are assuming here, I didn't write this down, but both A and B would be a member of E, right? Now notice you can verify yourself if you want that this definition of primality I think fits. It's called not prime. We're doing it. M is not prime, and element E is not prime, provided you don't get a factorization like this, where A and B are strictly between 1 and the value itself. Okay? Now, in that sense, it's not hard to verify that 2, 6, 10, 70, and 210 are considered prime. Now, the only prime in all of the integers would be 2, right? But notice that 6, 10, 70, and 210. Now, you'll see why I picked these numbers. But they're all prime integers in this set of positive even integers. They're considered prime. Now, let's just check it out for the largest one. Notice that 210 is the same as what? 2 times 3. Now, that's a number that's not an E, but it helps us here nonetheless. 2 times 3 is 6. 6 times 5 is what? 30. And then 7 times 30 is 210, right? So notice we could write 210. 210 could be written as 2 times 105. But notice 105 is not an E, right? 105 is not a member of E. It's an odd number. And also 210 could be written as, what do we have here? 6 times 35? 6 times 35 gets probably even another one, right? 6 times 35. But it's always going to be the case that it's going to be the product of an even and an odd number just because 2 is present one time here, right? It's guaranteed. 2 is present one time. And so there's probably another one here. But anyway, hopefully I've demonstrated that 210 is a prime in the set E, in the ring, shall we call it. And also the same can be verified for 70, 10, 6, and 2. Okay. Now what's the punchline? What's the punchline? And thank you for sticking around if you did. We can write down 420 is equal to 2 times 210. Right? Both of those are prime. So that is a prime factorization of 420 in the ring E. But also notice, what else can we get out of this? We can get 6 times, what do we need here? 6 times 70 maybe? Yeah, 6 times 70. Okay, 6.70, folks. Let me make that dot very prominent. So you see, you guys who are familiar with number theory are already going, what about this? Okay, we have 2 different prime factorizations for the same number. That cannot happen in the integers as a ring. But we have demonstrated it can happen in the even integers, the positive even integers. Okay? So what is the punchline? Okay, drum roll here. There's no unique factorization. This proves there's no unique factorization. Yeah, and I've never done this before. I like to state what I'm trying to prove. I thought I would try this approach, but there's no unique factorization, no unique prime factorization. Prime factorization. Running out of room here, folks. Factorization. Okay, no prime factorization in E, okay? So that's a big deal, right? You can't do it. And a lot of stuff depends on the uniqueness of this in regular number theory, right? So anyway, that is the, and y'all, again, I ran out of room. I was supposed to read prime factorization. I painted myself into a corner there. Do I get O-N? Oh, that's cheating. Okay, but that's prime factorization, no unique prime factorization in this ring. Now, some people, I think, debate whether or not this is even a ring. I think there are algebraists who talk about rings without multiplicative identity, so I don't want to quarrel about that. I think most of the time a ring is endowed with a multiplicative identity, but in this case, this would definitely be a ring if you permit it to not have a multiplicative identity. But anyway, that was our goal, was to show an example of a prime factorization, a number that can be written at least two ways as product of distinct primes. Okay, thank you for viewing.